returning objects. The previous example, we have seen that a method may take parameter. The parameter can be of a fundamental type or a class type. Class type means say object type. We have passed objects as a parameter to a method. So far we have seen the return type of a method is void or some integer, float, or some other fundamental types. Now the question is, can a method return any type of data including the user defined class types? User defined class type, for example, class triangle. The question is, can a method return a triangle type? That is a question. Return type is void something, right? Fundamental types. Here, is it possible for a method to take the return type as a class type? The answer to this question is yes. Yes, a method may return the entire object as a returned value to the calling phase. Normally, write a function return only one value to the calling phase. In case of structure, a structure returns the entire structure, which means more than one value can be returned to the calling phase. But in case of method type as the same class type means, so the entire content of class, that means the entire content of an object can be passed as a value, or can be returned as a value to the calling phase. So instead of having the fundamental types or having some void no return type, we have to pass we have to return, make the return type as same class type. See in this example, a class triangle which defines three instance variables A, B, C. One triangle class constructor is defined. Then another constructor, overloaded constructor, having three variables. We defined initialized A is equal to X, B is equal to Y, and C is equal to Z. Then the values of A, B, C are printed. Then consider the method scaling. Scaling is our user-defined method, which takes one integer parameter. But what about its return type? It seems strange because the return type is same as class name, triangle. So whenever a method takes the return type, which is equivalent to the class name, class type means you must have a return statement. In that state, the return statement returns the entire object as the return value to the calling entries. So here you must have one return statement, a return that object name, return expression. That expression should be an object of this triangle class. So here I have created one local object, triangle temp is equal to new triangle. What is temp?
Object.
Object.
Yeah, object. Yeah, of course, a temporary object because the scope is limited within this opening and closing curly braces. Here I do like to change the value of this temporary object contents because objects instance variables are A, B, C. We like to access temp.a, temp.b, and temp.c. Based on a scaling factor, for example, we like to scale a triangle based on the scaling factor x. So actual instance variables, say A, B, C are representing the sides of a triangle, and the sides are multiplied by the scaling factor. Temp dot A is equivalent to A dot x, temp dot B is equivalent to B dot x, and temp dot C is equivalent to C dot x. Return temp. Normally, a method returns only one value, maximum one value to the calling phase. Return, dummy return will not return any value. Return semicolon is also valid. That stage, return type should be of void. Void scaling empty x. Return semicolon, okay, dummy return. Just the control is unconditionally transferred to the calling phase. Here, return some temporary object, temp. So, entire content of an object can have more than one variable. So, this is one possible way how a method can return more than one value to a calling phase. When a method returns an object means then more than one value can be returned from the method. Possible. Return temp, right? The temporary object is returned to the calling phase. Now see the effect of the calling statement. Triangle T1 is equal to new triangle 1, 2, 3. T1 dot display. Triangle constructor having three parameters. Here, parameterized constructor. The instance variables A, B, C are set as say, what about the values 1, 2, 3. Triangle T2 is equal to new triangle 4, 5, 6. Second triangle objective T2 is constructed with sides say 4, 5 and 6. Again invoking this parameterized constructor. T2 is equal to T2 dot scaling of 5. What is T2? Or T2 is the invoking objective. Scaling is the method and 5 is the actual parameter. So in that stage what will happen means simply the invoking object is T2. Parameter is 5. T2 dot scaling of 5 means this method is called T2 dot scaling of 5. Now a temporary object is constructed. The changes are made entirely in the temporary object. Temp dot A, temp dot B, temp dot C. And 5, right? 5 is the actual parameter. The processing is over here. A dot X, B dot X, and C dot X. Because of this return temporary object, this object is returned to the calling place. The important thing is which object is calling this method scaling. T2 is calling the method scaling. So here the left hand side object, if you want to can specify, that should be of the same triangle type. For example, again I am receiving the object in a T2. T2 is equal to T2 dot scaling of 5, a T2 dot display. Now what happens? The updated values of T2 are printed. Java classes 14 Java classes 14. Initially the sides of a triangle are 1, 2, 3. Then sides of a triangle, the second object 4, 5, 6. Then after calling this method, T2 is equal to T2 dot scaling of 5. What happens? T2 is updated 5 times. We are performing the scaling operation. So 5 into 1, 5 into 2, 5 into 3. Sorry, on which object say T2, right? Not on T1. So 5 into 4, 5 into 5, 5 into 6. Because T2 is the invoking object. T2 is scaled, right? 5 times. 5 into 4, 5 into 5, 5 into 6. So after this calling T2 dot display means we have the quantity, right? 20, 25 and 30. This is a scaled triangle object. Then a triangle T3 is constructed. T3 is equal to new triangle 7, 8, 9. T3 dot display. Then T3 is scaled based on the object T2. So we have defined another overloaded version. Scaling int x comma triangle t, which takes one triangle object as a parameter. That object is T2. The thing is, T2 is multiplied by 10. 10 times the object is scaled because of these statements, same statements. Triangle temp is equal to new triangle. Temp dot A is equal to here T dot A into x. What is T dot A? T dot A is received from the actual parameter. That is T2. T2 dot A into x. Here T2 dot B into x. T2 dot C into x. Clearly the object T2 is scaled 10 times and the result is updated into a variable T3. T3 is equal to T3 dot scaling of 10 comma or 2. Now the returned object is received in the left hand side variable T3 because T3 invokes the scaling method. The resultant object is received in T3. Explicitly we have mentioned T3 is equal to, because of this temporary object, a return temp, T3 gets updated. T3 is scaled 10 times based on the values of T2. T2, what is T2? Updated values of T2. T2 updated values are this one, say 20, 25 and 30. 10 times we are scaling the updated object to T2. So it becomes 200, 250 and 300. So in this example, what you have to understand means, here this is a method, scaling. Previously a method takes the class type as a parameter. Here the method may returns the entire object as a return value to the calling place. That is possible. The same is also supported in C++. In C++, a member function can return the entire object as a return value to the calling place. Having any queries in this example? Understand?
No, sir.
Having any doubts? Okay. I have a doubt, right? For example, let me change this one to this one. We try to learn all possibilities because we are saying that the method returns the entire object to the calling place. I do want to write a statement like this. I am using the left hand side variable. T2 dot scaling of 5, same statement. Say T2 dot previous line, 2 lines are commented out. Now what will happen? Will it result in a compile time error or this will be okay? Okay, 1 minute. Suppose here the return type is void. What will happen in the calling statement? You need to use as it is. Object name dot method means some parameter list it is. Suppose if the return type is an integer line, int scaling, some intakes. In that stage, what you have to do? Whatever the left hand side variable must be
Integer.
integer one. So at the basic level, it must be an integer one. Say int y is equal to something. If it is a float, it should be a floating point variable, right? Here, this is an object. So my question is, should we have the left hand side variable, the object of the same class? In case if we present the left hand side variable, the left hand side variable must be an object of the same class, that is a root. Another thing is it necessary to have the left hand side variable an object of the same class with this representation? Object is equal to, highlighted thing, is it necessary?
Sir.
No, sir.
No,
Because T2 gets stored, sir. The
because
value. T2 is stored by the value, sir, after scaling.
yeah, we have the logic. T2 dot scaling of 5 means T2 is calling the method scaling. So the caller of a method scaling is done by the object T2, and this return temp means the result is returned to whom? The caller. The caller is T2. So let us check the proof if it is okay. Before that, right, let me check. I have saved the file saved. No compilation errors. So here also you can see the same output 1427 14 14. What about the next stage? Results are changed. 1 2 3 4 5 6. Third line 20 25 30. But here the third line is 4 5 6. But no compile time error. T2 dot scaling of 5. Have a look into these two outputs. These two outputs are not the same. First printing the object of T1, then printing the object of T2, then third one previously 5 times scaled object of T2. Here the third line, I think 4, 5, 6, again printing the same contents T2. But this is
I think it is printing due to T2.display of, sir.
yeah, T2 dot display. No changes are made.
The
That
top
means
one, it is not commented out, I think, sir.
the returned object is not actually processed in T2. Returned object is not captured. Understand or not? So this will not result in a compile time error, but you have to understand carefully. So T2 dot scaling of 5 means okay, T2 is calling this object is scaling. So in this stage, one temporary object is there. That a temporary object is returned to the calling place, but which is not received in any of the variables. That's what. After this method call, T2 remains the same. Say 4 5 6. Likewise here if you miss T3 is equal to T3 dot scaling, let us check. T3 is equal to commenting out this one. T3 dot scaling up 10 comma T2. File save. Yeah, no changes are made. 1447 40 1447 789. Again here the returned object is not actually stored in some other object, even though a T3 is calling, right? But after this method call, the changes are the returned object will not be stored in the actual parameter object T3. So this is very important point. Understand the differences? Having any queries in this? Let me mark here. There is no error, but the returned object is not assigned or not updated in P2. The same explanation is here. T3 is equal to T3 dot scaling. Here the returned object is processed in the left hand side variable. So similar to that of fundamental types. So you should be very careful. The left hand side variable must be an object of the same type. Otherwise, the returned object will not be processed. If you specify some other object of the class here, then that results in a compile time error. Returned object cannot be stored in some other object of the class. So this is to be how a method can return an object to the entire, how the method can return an entire object to the calling piece. So in that stage, you should be ensuring that the left-hand side variable must be an object of the same class. Having any queries in this? Yes. Any queries you
Sir,
can ask.
when return type is void in T2 dot scaling, T2 gets updated or not, sir?
Return type is void. Then what is your question?
Then T2 gets updated now, sir.
T2 gets updated here in T2 dot scaling of 5.
Yes, sir.
T2 gets updated only when, in case if your left hand side variables are the instance variables of the same class. Suppose normally, right, as we have seen in circle, rectangle classes, suppose A is equal to something, B is equal to something, C is equal to something, assuming the return type is void. In that case, here normally T2 dot some method name something. T2 is the caller of this method. So any left hand side variables which are of instance variables are completely not only left hand side, even in the right hand side variables. Wherever instance variables are mentioned, those instance variables are referred by the invoking object. In that case, the changes are made in the invoking object T2. So T2 dot scaling, right? After that, you will have the updated values of T2. Sure, there T2 updates its
Yes,
contents.
sir. That was my doubt, sir. T2 gets updated.
Yeah, T2 gets updated. Yes.
Okay.
But even in this T2 dot scaling of 5, processing is made, right? You can check. Control goes to call this method. You try to check, right? Do it yourself. Here, right? Give one message. System.out.println. Scaling method is called, right? You try to check that. So simply T2 dot scaling of 5, right? You can find out that message, right? If the method is actually called. But a return temp return returns an object. That object is not processed in the calling statement without any compile time error. So that's what T2 remains the same value. No updation is made into the variable. But Not only here T2, right? Here also you can specify T1. T1 is equal to T2 dot scaling of 5. That is also correct one. So in that stage, the scaled object is completely returned to a new object, say T1. That is possible. Any other queries?
So in that case also the updated values will be there in T2, but I mean T1, but T2 will not be updated, sir.
T2, yeah, T2 remains the same. So let me check it. For example, having another class or triangle T4 is equal to new triangle. Do we have the default constructor? Okay. Triangle overridden. Now writing T4 is equal to say T1 dot scaling. Let us call the first person T1 dot scaling. Suppose scaling. Then what to print? T1 dot this and T4 dot this. Let us check T1 dot this. Then a T4 dot this. Let us check last two lines of output. Last two lines which indicates that what is T1? I think T1 is not affected in the code. T1 remains 1, 2, 3. So T1 remains 1, 2, 3. Here T4 scales object T1 10 times. So printing T4 dot display. Last line 10, 20, 30. But last but one. This output T1 dot display. T1 dot display remains 1, 2, 3. Okay.
Sir,
Any queries?
sir,
Yes.
sir, if we triangle T4 is equal to new triangle of, in that if we give us T4 dot scaling of 10, then T4 dot this, then how it will be printed, sir? Value.
In the constructor value, you want to give T1 dot scaling of 10.
Instead of T1, T4 dot scaling of 10, sir. You see, T4 is equal to not needed, sir. T4 dot scaling of 10 only.
Here, this line.
Yes, sir.
T4 is equal to T4 dot scaling of 10. Am I right?
Only T4 dot scaling, sir. Not T4 is equal to.
Only T4 dot scaling.
Yes.
Okay.
Then we display.
T4 value is not initiated. So the values of T4 is not initiated. So garbage value will be there, no, sir. In T4 initiated.
Yeah, T4 no, no values. Let us check anyhow. What about this 1, 2, 3? Last but one corresponding to T1, no change. T4 dot display.
Oh.
T4 some garbage values 0, 0, 0. So it seems that T4 is not initialized. When you do not initialize anything, this default constructor is called. The default constructor initializes A, B, C to 0, or you try to set A is equal to B is equal to C is equal to 20. The same initialization remains in the object T4. That's what I said. The method is called, even you try to check yourself, the method is actually called. Give one message right here, what to do, system dot out dot println. That's a way to check right if the method is actually called or not. I am called. Save. What happened? File has been saved. Am I right? Java C classes 14.java. classes 14. I am called, how many times it comes? I am called 1, I am called 2, twice they has come. Is it? Twice in the sense that actually, okay, T2 is equal to T2 dot scaling of 5, right? So one stage it appeared. Second stage, T3 is equal to T3 dot scaling of 10 comma T2. The method is actually called. That's what we have the message. So sorry, this is not calling, right? The first version, this is a overloaded version. Second time, right? T4 dot scaling of 10. The actual method is called. I am called print the value of this. Better you can conclude. T4 dot scaling of say 100. So wherever you have a doubt, right, what you have to do is you better to print the values of the variables. That is one possible way to clarify what has actually been executed by the Java system. So first stage, right, T2 dot scaling of 5. You can see the message. I am called, right, 5. That is okay. Then here, this is scaling of 10 comma T2, but this is the overloaded version. You try to give the println message here. This method will be called. And second stage, T4 dot scaling of 100. I am called 100, right? So it seems that T4 dot scaling of 100 called this method. The objects are created and the temporary object is returned to the calling phase. But unexpectedly, the temporary object is not processed or not assigned to the invoking object T4. That's what the last line T4 remains, right, 0, 0, 0. Or you can provide a T4 is equal to 100, 200, 300. In this stage, right, a T4 is 100, 200, 300. T4 remains unaffected. Okay, T4 is 100, 200, and 300. But T1 remains the same, 1, 2, 3. There is no effect of this returning object. The returned object is not actually processed in the calling statement. So this is not a good logic, right? Since the method is trying to compute something and the value is returned to the calling phase, so have a logic of, right, the left hand side variable, which is an object of the same class. So using these concepts, right, methods taking parameters, methods taking objects as parameters, methods may return an entire object to the calling phase. We can go for implementing more iterative concepts and even some recursive concepts are implemented so that some of the complex problems can easily be solved by implementing these strategies, passing objects as a parameter and returning objects from the method. Having any other queries?
Sir, in case the methods are not returning user-defined objects, instead they are returning data types like int, float. Even then, if you are not assigning the function call to decide data type, it won't show error, sir.
Which one I can't get you? Please tell me clearly. Whatever the return
Sir, for
type,
example, if the return type is something like a basic data type, like int, float,
fundamental type.
double,
Okay.
fundamental types,
Hmm.
then is it necessary that we have to assign it to the decide data type, or we can just leave it as a function caller also?
Sure, there it will return a compile time error. For example, here one small method, let us test it. Suppose the return type is int g. We are returning the value. Say return some 9. This is okay. G should be called. How to call a G? For example, one object is say T4. T4 dot G. What will happen? Let us check it. I think compile time error is a result because method is returning the integer value. So no compile time error. T4 dot G. Check if it has correctly placed. T4 dot G. Return 9. Okay, 5, save. no errors. Java classes 14, no error t4.g. But anyhow, t4.g means the method is calling, right? But we can check right the system.out.println message will be invoked. Unexpectedly, right, the return value is not processed in the calling statement t4.g. In case if it is placed inside the system.out.println, the value is processed. Or the left-hand side variable say int t is equal to t is equal to into t is equal to t4.g, then printing the value of a variable t, t will be printed. So for the fundamental types also, it's not necessary if you have the left-hand side part variable is equal to, not necessary. However, the method is calling. Simply write the returned values not processed, not assigned. That is the thing. We can check the same in C++, right? We don't know right how the C++ compiler is treating, producing the compile time error or the same concept, right? Accepting or not. We need to check it. Okay, having any other queries? Whenever a method takes void, we can also use a dummy return statements. Void, for example, fetch, void fetch, dummy return, no expression. Right? This is perfectly valid. For example, t4.h. Let us check it. File has been saved. File save. Okay. This is accepting. This is the dummy return, but a return type should be void one. In case of the return type is some float, what will happen is float h, save the file, compiling the code, results in an error, compile time error, because return type is there, a float, but you are returning a dummy value, right? A return, missing return value. Understand or not? So for dummy return types, the return type void is okay. For other cases, we need to specify the exact expression. So with this, let us complete the today's session. If you have any queries, you try to ask me. I will clear your doubts. In the next session, I focus on static keyword and final keyword, recursion, iteration, right? That is our next focusing. Recursion, iteration, static keyword, final keyword, and some other keywords. And even in the overloading, right? We have the extended concept, right? Where works a concept, right? We will discuss in the next class. Okay, thank you very much. I will share the files right after the session.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.